Welcome everyone. We are discussing problem involving symbol of combination. In the previous class, I have solved some problem using this symbol NCR and using 4 theorems. Today through this video, I will solve some more problem using this theory. So, in previous class, I have solved this one. NC4, NC5, NC6 are in AP. Find N. Now, this one. This is general one. NCR minus 1 is to NCR plus 1. 3 is to 4 is to 5. Find N and R. So look, it is given that NCR by NCR minus 1 equals to 4 by 3. 4 by 3. Now using the above theory, this is N minus R plus 1 by R equals to 4 by 3. So we are getting 3n minus 3r plus 3 equals to 4r. 3n minus 3r plus 3. So 3n minus 7r equals to minus 3. So call it 1. We are taking ratio of two consecutive terms. Again, NCR plus 1 by NCR equals to 5 by 4. Now, difference of suffixes of the denominator by lower suffix of numerator equals to 5 by 4. So, we are getting one more equation. 5n minus 9r. This is 4r, this is minus 5r equals to 5. So we are getting two equations and two unknown. So we have to solve it. Nine R. So this is 5n, this is 3n. So multiply it by 5. So 15n minus 35r equals to minus 15. And multiply it by 3. So 15n minus 27r equals to 15. So subtracting, we get 8r equals to minus 8r equals to minus 30. So let us verify again. R is not integer. So 3 is to 4 is to 5. So this is 4 by 3. NCR, N minus R plus 1 by R equals to 4 by 3. So 3n minus 3R. So 3n minus 7R equals to minus 3. So this is equation 1. Next, NCR plus 1 by NCR. So N minus R by lower suffix R plus 1. So 5 by 4. So 4n minus 4R. 4n. Sorry, this is 4n minus 4R and minus 5R. So 4n minus 9R equals to 5. So this is 4n. And this is 3n. Sorry. So you multiply this equation by 4 and this equation by 3. So 12n minus 27r equals to 15. 12n minus 27r equals to 15. And it is by 4. So 12n minus 21r. 28r. 12n minus 28r equals to minus 12. So subtracting, we are getting r equals to 27. What is value of r? R is 27. So r is an integer. So it is possible. So putting value of r, we get n. So put value of r. So 4n minus 9 into 27 equals to 5. So 4n equals to 5 plus 4n equals to 2, 4, 8. So what is n? 72. So n equals to 72 and r equals to 27. So you remember this theory, NCR by NCR minus 1. Otherwise, it will take time. Next one. Now, next problem. NPR equals to 2520, NCR equals to 21. Find n and r. So you expand the symbol. Factorial n by n minus r. 2520. This is factorial n by factorial r into n minus r equals to 21. This is 2. So 2 division 1 division 2 implies 1 division 2, because factorial n will be cancelled out, factorial n minus r will be cancelled out. So we are getting factorial n minus r. This is n minus r into factorial r by factorial n. 2520 by 21. So this implies factorial r equals to 120. So this is factorial 5. So what is r? R equals to 5. R equals to 5. So find n and r. So we are getting r. So now putting value of r in 1. So from 1, factorial n by n minus 5 equals to 2520. So we have to expand factorial so that we get a relation not involving factorial. So if we expand it, this is n minus 1, n minus 2, denominator is n minus 5. So n minus 3, n minus 4 into factorial n minus 5 by n minus 5 equals to 2520. So we are getting a 5th degree equation. So it is not easy to solve, but here we use comparison method. What is comparison method? LHS is a product of n consecutive integer. We have to express RHS in terms of 5 consecutive integer, because it is product of 5 consecutive integer. So 2520, 1260, 630, 315, 3105, 33557. Now our main aim is to express this right hand side in terms of 5 consecutive integer. So this is 7. So 1 is 7. 3 into 2, this is 6. Then 5. then 5, 2 into 2, this is 4, this is already used, so 1 3 is remaining, this is 3. So 7, 6, 5, 4, 3. So n minus 1, and they are in descending order. Sorry, they are in ascending. So n minus 1, they are in descending order. This is also in descending order. So what is n? N equals to 7. N equals to 7. N equals to 7. You can write n minus 4 equals to 3. So n equals to 7. So if you get problem involving factorial, then and you are getting suppose 3rd degree, 4th degree, 5th degree equation, then try to solve it by comparison method. Now one more problem, 6a and b. So they are exactly same, but here we have to expand only. Expanding you have to solve n. So because we cannot use the previous theorem directly. So consider problem number B. nc6 by n minus 1 c3 equals to 91:4, find n. So nc6 factorial n by n minus 6. This is 6 into n minus 6, and this one implies will be here expansion n minus 3 factorial, then factorial 3 into n minus 6, factorial 3 into n minus 6. So 91/4. So n minus 6 cancel. So factorial n into factorial 3. Factorial n minus 3 into factorial 6 equals to 91/4. So this will be at the numerator and this is at the denominator. So our main aim is to remove factorial. So to remove factorial, you have to expand getter factorial. So which one is getter? N and n minus 3. So n is getter. So this is n minus 1, n minus 2 into factorial n minus 3. And n minus 3 unchanged. Factorial 3 unchanged. This is 6. So 6, 5, 4 into factorial 3 equals to 91/4. So cancel out. So what we are getting? N into n minus 1 into n minus 2, 91/4 into 6 into 5 into 4. So 4 cancel. 4 cancel. So we are getting n into n minus 1 into n minus 2, 91. So 91, 7 into 13, this is 91. 7 into 13. So 7 into 13 into 6 into 5. 7 into 13 into 6 into 5. So they are not consecutive. They are not consecutive. So we can write so let us see again what is our problem. Now look, we are getting up to this n minus 3, n minus 1, n minus 2. Factorial n minus 3 is cancel out. So 91 by 4, 653. So 91 into 7 into 13, 6 into 5. Now 6 is 3 into 2 into 5. Now I have already stated our main aim will be to express right hand side in terms of product of 3 consecutive integers. So n minus 1, n minus 2. So look, this is 13 and 7 into 2, this is 14. So 14, then 13 and 5 into 3 is 15. So LHS is a product of 3 consecutive integers, 15 into 14 into 13. So what is n? n equals to 15. So you always try to solve it by comparison method. So if you multiply it, you get a cubic equation, but we do not know any general method so far to solve cubic equation. So that is why this will be our main aim, to express right hand side as a product of consecutive term in compare with LHS. Next, now you consider one more simple problem. NP1, P stands for permutation by factorial 1, NP2 by factorial 2, NP3 by factorial 3, NPn by factorial n equals to 2 to the power n minus 1. So this is very simple problem of WBJE. So look, LHS, this is factorial n by factorial n minus 1. Expansion, factorial n by n minus 2, factorial n by n minus 3. And look, this factorial 1 unchanged, this factorial 2 unchanged, this factorial 3 unchanged. And this is factorial n by factorial n as it is into factorial 0. So this is expansion. Now we know NCR equals to factorial n by factorial r into n minus r. So look, actually it is NC1. Factorial n by factorial 1 into this. This is NC2. This is NC3. And this one is NCn. So NP1, NPR by factorial r. This is NPR by factorial r is NCR. We can use this result directly. Now, this is 2 to the power n minus 1, because there is a well-known theorem of binomial theorem. So what is the theory? NC0, NC1, NC2 dot dot NCn equals to 2 to the power n. So combination of n different things taking no at a time, none, 1 and n at a time, 2 to the power n. So NC0 is 1. So NC1, NC2, NCn equals to 2 to the power n minus 1. So this is well known result of binomial theorem. You know, number of subset of n different things taking any number at a time equals to 2 to the power n. You know, number of subset taking 1, 2, 3 and n. So NC1 to NCn, none at a time, that is 5 set equals to 2 to the power n. I will give proof of it when I will consider the chapter of binomial theorem. So you consider this result as standard one. Next, problem number 6. Prove that 2ncn equals to 2 to the power n into 1, 3, 5 product of odd number 2n minus 1 by factorial n. This is also most important result. We often use this result in binomial theorem. So consider LHS 2ncn equals to factorial 2n by factorial n into factorial n. So 2n definition is 2n, then 2n minus 1, 2n minus 2 consecutive, then last one is 1, this is 2, this is 3, this is 4, 5, 6. Starts from 1 and ending with n. So these are all obviously positive. Factorial n into factorial n. Now look, in numerator there are 2n terms, and if you notice it, half of them will be even. 2n even, 2n minus 2 even, then 2n minus 4, 6, 4, 3, 6, 4, 2, and half of them are odd. So out of 2n terms, half of them are even and half of them are odd. So we consider them into two separate brackets. So 2n minus 2, 2n minus 4, then 6, 4, 2. These are n numbers. And 2n minus 1, 2n minus 3, dot dot 5, 3, 1. Factorial n into factorial n. Now you notice that if you take 2 common, it will be n. It will be n minus 1. It will be n minus 2. 3, 2, 1. So from 2 terms we get 2 square. From 3 terms we get 2 cube. So n number of terms. So if you take 2 common, we get 2 to the power n. So n minus 1, n minus 2, dot dot 3, 2, 1. And these are product of odd term. So you leave them. 5, 3, 1. Then factorial n into factorial n. Okay. Now listen. This is n to 1 or 1 to n. Product of n consecutive numbers starting with n and ending with 1. So this is obviously factorial 1. And we can write it in reverse form also. In product, this is commutative, so you can interchange the position. So factorial n into factorial n. So 1 factorial n is cancelled out. So what we are getting? We are getting this final result. 2 to the power n, 135 dot dot 2n minus 1 and 1 factorial n is remaining. So this is our right hand side. So this is most useful result. So you solve problems from any standard book using symbol. Today, through this video, I have solved some important problem of combination using symbol. So thank you for today.